Hey everybody, this video lesson is going to cover the 5 different types of reactions. Over the next week or so, we're going to be talking about 5 different types of reactions, and they all are a little bit different. Your job is to be able to identify the 5 different types of reactions based on how many reactants, how many products, and what the chemical reaction looks like. It's called the reaction mechanism. The first one we're going to talk about is called synthesis. The second one is called decomposition. The third, single displacement. The fourth is called double displacement. And finally, everybody's favorite, the combustion reaction. I'm going to take you through all 5 types of reactions right now and give you an example of each. Hopefully by the end of this video lesson, you'll be able to identify the 5 different types and look for the clues to differentiate the 5 different types of reactions. The first reaction type that we're going to talk about is called synthesis. Synthesis, the word synthesis means to create. Another way to discuss this reaction is it's a combination of simple reactants. A dead giveaway that you're looking at a synthesis reaction is that you have one product. And so what you look for are 2 or more reactants and only one product. So essentially you're taking many small things and combining them into one thing, which is why it's called a combination or synthesis reaction. In a combination reaction, you take reactant A and reactant B and combine them together to make reactant AB. And so this could be ionic. This could be a metal and a nonmetal to make ionic. This would be 2 nonmetals to make a covalent. But either way, you're taking a substance and combining it with another to make a substance combined. So an example of a synthesis reaction is if you take Na, which is sodium metal, that's a solid, and add it to some chlorine gas, and what you get is sodium chloride. This is a synthesis reaction of combining sodium and chlorine. Now don't be too confused here that there are 2 chlorines on the left-hand side and only 1 chlorine on the right. And that's okay. This is what is known as a skeleton reaction, as we already talked about in a previous video lesson, so I wouldn't worry too much about that. The important thing is that you have 2 reactants in one product and identify it as a synthesis reaction. The second reaction type is called decomposition. The word decompose means to break apart or to make more simple, and that's what you're doing. You're taking a reactant and breaking it into multiple products. So when it breaks down to make simple products, you should have more products than reactants. What you look for is one reactant and producing more than one product. I made a note here that it looks like it's an opposite of a synthesis, and that's really what you can think of it as. If synthesis is 2 things combining to make one, decomposition is 1 thing splitting apart up into 2 or more. So a combination of A and B together would decompose into A plus B separate. So an actual example is a substance known as calcium oxide, breaking apart into calcium solid and oxygen gas. Again, don't be too worried about the fact that there's only 1 oxygen on the left and 2 oxygens on the right. Just know that there's both calcium and oxygen on the left side and calcium and oxygen. The quantity doesn't matter at this point. But we've got 1 thing splitting up into 2. That's a decomposition. Now we're going to step up into a more complex reaction type, and these next 2, single and double displacement, are much, much more complex. And really what you can think about is kind of a relationship sort of situation. That analogy will make more sense to you when I start using actual examples. But in a single displacement, what you have is a metal and an ionic solution to start. So what you look for is a metal replacing a cation in an ionic solution. And what you look for are the products that are also a metal in an ionic solution. So really, the front half and the back half look a lot alike, but it's important to keep track of which metal is alone to start and becomes an ionic part of a solution as a product. What you look for is a metal that is pure at the beginning but becomes part of an ionic solution on the product side. Here's the general form of the single displacement reaction. You've got A, which is a metal, and AB, which is an ionic solution. And so the states of matter here will be aqueous and solid, respectively. And then on the product side, you have also a solid and an aqueous solution. But take a look at what's happening. You've got the metal A, which starts out as a solid, but in the product side is part of an ionic solution or an aqueous solution. And B, which was part of the ionic solution as the reactant, is now a solid on the product side. Think about it this way. You're B and you're dating person C. B and C are happily dating. In steps A happens to be an old boyfriend or an old girlfriend of the person you're dating. And A comes back into the picture and goes, listen, I'm taking your girl or I'm taking your boy, and kicks you out. So now you're all by yourself, and A now is with your significant other. So it's a single displacement. A kicks B out, leaving B by itself, and now A is with C. Now the reason that I put A with C is A is a metal, so that makes it a cation. C is always going to be listed second because it's an anion, and anions are always listed second. A practical example of this is Na solid plus CuNO3 aqueous. So you've got a solid metal and an aqueous solution. On the product side, you've got an aqueous solution and a metal. And it doesn't matter if the metal is listed first as a product and the solution is listed second. These are interchangeable. So oftentimes I might write the individual metal first and the solution second, or I might write the solution first and the metal second. It doesn't matter. The order doesn't matter. The fact that copper was an aqueous solution and is now by itself, that is an identifier of a single displacement reaction. Reaction type number 4 is called double displacement. And it looks a lot like single displacement in that you have the same number of reactants and products on both sides of the reaction arrow. In fact, what you have is two ionic compounds on the left side of the reaction arrow and two ionic compounds on the right-hand side of the reaction arrow. So you have two complex reactants and two complex products. You look for the cations to switch partners. Here's what I mean. Take, for example, substance A, B, and C, D. A is the cation, B is the anion. So A and C switch partners. So A is now combined with D, as you see over here, and C is now combined with B, which is over here. Now it is important that you put C before B because C is the cation and B is the anion. Now I know B comes before C in the alphabet, but that's not important. It's the fact that C is the positive ion or the metal and B is the anion. So A is now mixed with a new partner and C is now mixed with a new partner. The analogy here is you go to a dance with your best friend and his date or her date, whatever, and during the middle of the dance you switch partners. So you switch partners with your buddy or you switch partners with your friend and you switch dancing partners. You both don't switch dancing partners because then you just end up with the same person that you're dancing with in the first place. But person A switches with person C, so now A is with D and C is with B. Here's a practical example. The reactant side, you have two ionic substances. You have copper chloride, in fact this is copper 2 chloride, and sodium hydroxide. So you've got copper chloride, sodium hydroxide. Now copper and sodium switch spots. So now copper is now with the hydroxide in the form of CuOH2, and sodium is now with the chlorine in the form of NaCl. So you've got two ionic reactants, two ionic products. And that's how you know you've got a double displacement reaction. Next up is everybody's favorite and the fifth type of reaction, and it is known as combustion. And I've drawn a little fire over here. So this reaction happens when O2 is part of the reaction side on the left-hand side of the arrow, and CO2 and H2O are produced. What you look for is the arrow and CO2 and H2O on the product side. If you see CO2 and H2O as products, it is a guarantee that it is a combustion reaction. Now the reactant side may be oxygen and any other substance. Typically, it is a fuel known as a hydrocarbon. That fuel usually is something that has carbon and hydrogen in it. It's known as a hydrocarbon. Hydro meaning hydrogen, carbon. It's a molecule of hydrogen and carbon. So the fuel plus O2 gives you CO2 and H2O. Now wood is mostly carbon and hydrogen. All of your fossil fuels are carbon, hydrogen, and sometimes oxygen. All of your alcohols are carbon, hydrogen, and sometimes oxygen. So hydrocarbons have carbon, hydrogen, and sometimes oxygen in them, and they also react with oxygen to produce CO2 and H2O. And so a real-world example is one that you use to heat your homes. CH4 is natural gas. CH4 is with O2 and makes CO2 and H2O. Another example is C8H18, which is also known as octane. Octane is the gasoline that you burn inside your cars. So octane plus oxygen gives you CO2 and H2O. But notice in both cases, the products are CO2 and H2O. Well, that covers these 5 different types of reactions. Hopefully you'll be able to identify the 5 different types based on how many reactants and products and what they look like. That takes care of this video lesson. Thanks for listening.